Hello everyone, I am Darshan, student of Mathematics Department of Ferguson College, Pune. Today I am here to present car black box, a simulation project presentation that I have developed during Embedded System Internship conducted by Emertxe Information Technologies. So let's see the contents of this presentation. Firstly, we will see topics that I have learned during this internship. Then introduction to our project, need of our project, then what is embedded system, then microcontroller and microprocessor, then how to choose an embedded system, then requirements in detail, then embedded program, and demo, and then output screens, and then we will see application of this project, then conclusion of this project, and at last we will see the references. So firstly we will see the topics that I have learned during this internship. So I have learned embedded C programming, introduction to microcontroller versus microprocessor, embedded systems, types of embedded systems, microcontroller PIC16 F877A in detail, then types of memories like EEPROM, PROM, MASROM, SRAM, DRAM, flash memory, interrupt handling, then components like LEDs, digital keypad, timers, potentiometer, CLCD, I2C protocols. So let's see introduction to our project. So what is car black box? A car black box is a device which is installed in your vehicle, that is your car, which will monitor few events, which will monitor your driving, like it will record event like accident. If accident will happen, it will record it. Speed it will record, mileage it will record. Few car black box record location too. It is also called as event data recorder. So let's see need of car black box. So car black box mostly focuses on enhancing safety standards of driven vehicle by monitoring vehicle performance and driving behavior. Whatever records recorded by this box can be viewed by law enforcement agencies in case of any issue. If there is an issue, your insurance company can also check this box, and if you are done insurance of your vehicle, you will get the money. So let's see what is embedded systems. So embedded system is a combination of any hardware and software which is intended to do a specific task. So here you can see a schematic diagram of an embedded system. So let's see a general purpose system. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. What are types of embedded system? So there are four types of embedded systems: standalone embedded system, real-time embedded system, network embedded system, and mobile embedded system. So let's see microcontroller and microprocessor. So microcontroller is an integrated circuit which is capable of being programmed to perform a specified task. It has design restrictions such as memory size, I/O capabilities, peripheral functions, etc. So we can choose a microcontroller based on applications, performance, price, availability of the tools, and special capabilities of that microcontroller. So let's see microcontroller versus microprocessor. The main difference between microcontroller and microprocessor is in microcontroller all the components will be in single chip, which results in less flexibility and less design complexity. So here you can see in this image the components of microcontroller are in a single chip, while in microprocessor all components are assembled separately, which results in more flexibility and more design complexity that you can see over here in the schematic diagram of microprocessor. So let's see how to choose an embedded system. So there are five factors which affect while choosing embedded system. So an embedded system should consume low power. It should be cost efficient. It should also have a factor efficient use of processing power. The system should be reliable. and it should use memory in efficient way. Now let's see requirements. In hardware we require LCD display, 6 switches, then potentiometer, double EEPROM memory, microcontrollers and real-time clock. For simulation software we require MPLAB XID version 6, then MPLAB XC8 C compiler, PiximLab PIC 16F877A microcontroller and 16 by 2 LCD. Knowledge of embedded C is a basic requirement. Let's see requirements in detail. So here are the requirements of this project in detail. So first is default screen. When the system is in operation mode, it would act like a dashboard which would show the current time, speed of vehicle and latest occurred event. Let's see next requirement, login screen. On press of up or down keys, the system should prompt user to enter password. The password would be combination of 4 presses. Each press should be denoted by a star symbol. Every wrong entry would be result in re-prompting the user to enter the password again. Incomplete key press would lead to default screen. So let's see next requirement, main menu. The main menu should contain two options, view log and clear log. The up and down keys are used to navigate through this main menu. A long press of up key should enter selected menu. A long press of down key should log out. Idle screen for more than 5 seconds should log out. So let's see next requirement, that is view log. View log should display all the events captured by the box with log index starting from 0 like event number, event signature, event time, speed at that event. The up and down key will be used to scroll the entry. Rollover on reaching the max log entries. Here we can store maximum 10 entries. The system should be live even while viewing the logs. A long press of up key should take out the user back to main menu. So let's see our last requirement, that is event capture. The required events have to be captured and stored in the memory. Every event should have a format as event signature, event time, speed at that event. The event should be captured real time, no matter which mode you are in. So let's see the embedded program and them. So for that we will go to MPLAB XIDE. So here is our project structure of car black box. Here all the header files required for this project are in this folder, or all the source files required are stored in the source files directory. So here main.c file is there. So here all the initializations are done over here of all the peripherals. Then here is the main method. Then in car black box definition C, all the functionalities of car black box are enlisted and defined. So without wasting time, let's see the demo of this project. For seeing the demo, we have to build this project and load the hex file in the PiximLab. So we have already loaded the hex file in the PiximLab like this, and here is the default screen of this project. So it is showing time, event that is currently on, and speed is 0. So we can vary the speed by using this potentiometer from 0 to 99. The maximum value of the speed is 99 and minimum is 0. So we can change the events by using these three keys. So by pressing first key will change the event to collision. By pressing per second will change the gears, and By pressing the third key, it will decrease the gears. So now we will go to the logs, view logs section. So for that we have to log in. So by pressing this switch, it will prompt us to enter a password. If I doesn't enter any password, it will redirect me to default screen after some time. If also again, if I enter incomplete password, so it will again reprompt me to dashboard screen after some seconds. Now one more thing, if I enter wrong password, it gives me only 3 attempts, so I have only 2 attempts left. So again, I don't remember my password, so my it will show wrong password, so my attempts are going to exhaust right now. So my attempts are exhausted, so the system blocked me for 60 seconds. After 60 seconds, it will again prompt me to enter the password. So let's enter the correct password now. So here is the main menu screen. So now by selecting view logs, here are the view logs. So we can navigate through view logs like this by pressing these keys. As we don't have logs, we just have one log. We can't see any changes, but we can do that. So just we will create some logs and store in the memory. So now let's see the logs. So by selecting view log, there are logs. Yes, there are logs stored in this system. So now we want to clear the logs. So how to clear them? So firstly, we will log in again. So by pressing down key, it is choosing clear log. So let's choose clear log. It will show message logs are cleared successfully. Now it will go back to main menu after some time. So as I have cleared all the logs, so if I choose view log, so it will show no logs are there. So now let us see the functionality of changing the password. So by selecting changing the password, it is prompting me to enter a new password. So I'll enter a new password. So I have to enter the same password that I have entered before. So it is showing password change successfully. So this is all about this project. Now let us see the output screens on this project. So first is default screen. It should display the current time, the latest event captured and the current speed. So the next is user login. The user needs to enter correct password to browse through the available menu. The next screen is main menu. If user enters correct password, it is going to see main menu. The view log screen, the log screen will show like this. The log, then timestamp, then event and the speed at that event. Then we have applications of our project. The black box can be easily installed in some automobiles to record various events. These events, which are electronically sensed, can often proactively detect any issue in the vehicle or monitor the plate, thereby doing proactive maintenance of the automotive vehicle. Let's see conclusion of this project. By implementing a black box which would log critical activities on the car and take appropriate actions in case of rash driving, the root cause of negligence in the driving would be meeting the daily schedule and go off duty or to earn extra money by illegal trips, etc. So by implementing the mentioned solution, it would be easy to keep track of how the vehicle is being used, handled, and control the efficiency of the vehicle. The proposed solution is to log all the critical events like the gear shifts with current speed, the engine temperature, fuel consumption per trip, trip distance, etc. The system should allow a password-based access to Transport Manager to view or download the log to PC if required. So the references that I have taken from Wikipedia of event data recorder, car black box, a sample technical specification. Yeah, that's all about this project. Thank you for listening and watching this presentation carefully. And a special thanks to Emertxe Information Technologies for giving me this opportunity and believing in me. Thank you very much.